guys. In 2017, a mysterious object zipped through our solar system at incredible speeds. Oumuamua. It is the first interstellar object we've ever detected. But by the time we realized it was in the neighborhood, it was already on its way out. And with limited data, we aren't actually sure what it is or where it came from. Now, several research groups believe it is worth sending a mission after it. But with Oumuamua over 6 billion kilometers away already, is it even possible to catch up? Scientists are proposing to catch up with it, and how we're planning to be more prepared next time an interloper flies by. Here are some basics you need to know. Oumuamua was first discovered by the Pan-STARRS 1 telescope in Hawaii. The name actually means a messenger from afar arriving first in Hawaiian. It's thought to be about 100 to 1,000 meters long, and it is most likely shaped like a disc or cigar shape. What really elevated Oumuamua from an observational curiosity into bona fide mystery, however, was what happened when it passed by the Sun. Oumuamua passed its closest point to the Sun on the 9th of September 2017 at the speed of 87 kilometers per second. But when it headed back into space, it didn't slow down like normal. Scientists watching it detected an inexplicable burst of acceleration, counteracting the pull of the Sun's gravity. Rob Warwick, who is credited with the discovery, said, "Its motion could not be explained using either a normal solar system, asteroid, or comet orbit. Comets are leftovers of the formation of planetary systems, which can be ejected from their home star's orbit by a gravitational kick. They also speed up when passing close enough by stars due to the volatiles in the melting and being released as gas and dust. So if we'd seen Oumuamua giving off the same outgassing, there would have been no mystery. But Oumuamua didn't show any characteristics about gassing. No coma and no tail. Readings from the Spitzer Space Telescope also indicated it was at least 10 times shinier than a typical comet. A few weeks after its discovery, a fierce debate quickly erupted among scientists. Was this an asteroid, a comet, or something a little less natural? An artificial creation? Proof of alien life? We don't know, but we do know it came from very, very far away. To find Oumuamua home star system, astronomers traced its path back over millions of years. It seems to have come from the direction of Vega in the Lyra constellation. Scientists found 4 possible home stars, and Oumuamua could have come from some as far as 81 light-years away. But there haven't been any definitive answers on its origin story yet. And now it is over 6 billion kilometers away, moving at 26 kilometers per second towards Pegasus. It holds importance as the first confirmed interstellar object to enter our solar system, so it is no surprise that scientists want to take a closer look at it. We noticed that only 40 days after it passed its closest point to the Sun, but by then it was already 33 million kilometers from Earth. We sent ground and space telescopes into overdrive, trying to answer the questions surrounding it before it escaped our grasp. But 2 months later, by mid-December, it was already too faint and fast-moving to be studied by even the largest ground-based telescopes. With limited data and more questions than answers, some researchers believe the only way to learn more about it more is to send a mission after it. However, catching up to Oumuamua and more is a significant challenge for 3 main reasons. The first obstacle is gaining enough speed to catch up. Oumuamua is over 6 billion kilometers away and careening through space at 26 kilometers per second. No chemical rocket that exists today can reach that speed, making a rendezvous difficult. And once we've caught up to Oumuamua, the second challenge is decelerating enough to actually study it. If we don't slow down, we'll shoot right past it and won't be able to collect any scientifically useful information. And thirdly, it is difficult to find such a small object in such a large galaxy. Remember, Oumuamua is just 1,000 meters long, at most, tumbling through the vastness of interstellar space. Still, these barriers haven't stopped research groups from making plans to catch up. While accelerating to the speeds necessary to catch up with more and more is difficult, it can be achieved through the use of gravity assist from other planets. The most famous examples of a solution come from Project Lyra, launched by the Initiative for Interstellar Studies. They've presented two different trajectories we could send a probe on. First, we accelerate the probe out of Earth's orbit and send it towards Jupiter. Once at Jupiter, the probe slows down enough to fall towards the Sun. Less energy is required to do that from here than from Earth, as Jupiter's orbital velocity is less than half of Earth, and as our probe approaches the Sun, it's traveling at its fastest. At this point, the rocket engines ignite to give it the biggest acceleration possible for the amount of fuel carried, a technique called a solar Albert maneuver. By harnessing a solar Albert maneuver in this way, researchers predict their probe will shoot out of the solar system at over 70 kilometers a second. Well, that is definitely fast enough to catch up with Oumuamua. There are still a couple of problems with this plan. Such a close approach to the Sun requires a heat shield to protect the probe. The good news is that the tech for such a shield exists, as the Parker Solar Probe used something similar. Next, sending a probe from Earth to Jupiter to the Sun and back out to Jupiter to be sent out in the right direction is quite a long trajectory. There's actually a shorter way to do it. And finally, this plan requires using maneuvers that have never been carried out in a real mission before, giving it a low technology readiness rating. There is, however, another way to catch up to Oumuamua. The second trajectory proposed by Project Lyra is as follows. Launch from Earth, swing around Venus and Earth, conduct a deep space maneuver to reorient the probe, swing by Earth again, then use a gravity assist from Jupiter to catapult our craft towards Oumuamua. This would make it easier to decelerate on approach to More and allow for better data capture. Project Lyra has identified at least 2 viable missions, with launch dates between 2030 and 2033 and an arrival at the Oumuamua at 2048. One of Project Lyra's mission designers, Marshall Eubanks, feels a mission to Oumuamua is inevitable. After all, researchers are crafting proposals for missions to planets of other solar systems. But even 100 years from now, Oumuamua will still be much closer than those destinations. But could there be a better way to get the data we want? What if we could have anticipated Oumuamua months in advance, rather than after it had already passed by? NASA estimates that an interstellar interloper, similar to Oumuamua, passes through the inner solar system once per year. Since they're so small, they are hard to spot. Until now, the Vera C. Rubin telescope, set to become operational next year, would be able to spot these objects a whole 3 months before the telescope that detected Oumuamua. If it happened once, it will happen again, and our solar system will eventually be greeted by its next interstellar visitor. Ultimately, it all comes down to what is the price we are willing to pay to scratch the itch of our curiosity. Researchers at Project Lyra are certainly considering the investment. Is it worth it? So if you like my videos, please like, share. Subscribe my channel for more videos like this. So thanks for watching.